Hello everyone. So today I'm going to further work on this animal IK system. So now as you can see, when we go up this angled surface, you can see the character's legs are also being angled to keep them vertical. So that part was not there in the previous episode, so I'm going to work on that part here. And also I'm gonna smooth out this change in the body angle so it doesn't snap to locations like before, so it smoothly change the character and body angle. So right, those are the parts I'm gonna work on today. And this episode is sponsored by this generous patron. Thank you very much for the support. Right, so far in our deer IK system we have implemented this. We angle the body of the deer according to the angle of the floor, but today I want to work on straighten out these legs. So that means the legs should be vertical even if the character is in a slanted surface. So right, let's go to the code. So this is the part where I rotate the character by setting this Euler angle of the root bone. So yeah, just like that. Yeah, just like this we should be able to modify this left thigh, left clavicle, these bones as well, right thigh and right clavicle. So yeah, if I move the character to a place like this, and from the root I will rotate the character to make it align with the surface. Like this. Then after that so as you can see the legs are not straight, so it's not clear there, but yeah, if I play the game you can see it, so it doesn't look natural. So this legs should bend this way to make them straight. So yeah, let's see how to do that today. Yeah, maybe let me check which bone I should rotate. For the front legs, we left thigh, right thigh, yeah. If I rotate from the clavicle, we can do it like this. Okay, so the current rotation of the clavicle is like this. So which one I should modify? Notice it. So it should be the X angle. Yeah, X angle, right. So now just like this, let's get the test it with the left right clavicle. TAR clavicle, local Euler angles equals before modifying we should get the current Euler angles. So can we do it like this? Plus new vector 3 angle 0 0. Let's see if we can modify it like this. It is rotated into the front, so that means we should use minus here. Yeah, it is straight now compared to the other leg. Okay, so I think we are, yeah, let's do that for all, for the left clavicle as well. For the left clavicle it should be again positive because of the right. Let's see how it looks. Okay, okay, the legs are straight but they are floating on the ground, so we might have to do a correction to the root location as well. Okay, let's apply the same thing for the thighs. So which angle I should change in the thigh? Is it X? Oh, not X. Is it? Yeah, is it? T L thigh. Angle. This could be plus or minus. Let's test and see. L, both L and R. Okay, something is happening, but I guess the angles are wrong. The minus value is wrong. So yeah. Oh, wait, which one I should change? It looks like both. Let's see. Right, it looks much better now. But yeah, if we go to the scene view, you can see the character is floating above the ground. So to fix that, well, first let's check if that difference is there when the character is walking on the flat ground as well. Oh, character is stuck there. No, it doesn't have any such a problem when walking on the flat ground. So this is where the problem is. If all four legs have the same amount of difference from the ground, then we could just move down the road, but it doesn't look like all of them have the same amount of difference. So what could we do? What can we do? Yeah, well, let's do a line trace from one hoof and move down the character a bit to compensate for that difference. Oh yeah, let's see what happens if this angle is increased. Let's see if that oh yeah, okay, right. Let's move the character here. Yeah, maybe we should be able to avoid this problem if we keep the deer road in the center at this point, but it should be already there. Let's see. Oh wait, let's put it right there. Right now this is the root of this complete deer character, and this is the root of the deer object. So if I move it down, it should be alright. Yeah, to visualize this, can we add some object here? A spear, a very small one. like this. Now let's move down this deer character like this. Alright, let's see now. No, still not fixed. Alright. Did I add any? I need to remove these modifications to see how they actually looks. Or can I just reload the scene? Wait, which scene is this? Is this sample scene? Yeah. But when I play the game, I think the character is on the ground. Ah yeah, let's check this in here. Yeah, now it's actually okay. Alright, so then I guess I have to move down the object through the code. To compensate for that change. Let's check again. Oh, it can't move that distance, that angle. Right, but for now I'm gonna forget about that part. So what next? Right. Oh, so as the next step, so as you can see here, once this character go there, well, that is not a problem here. So if I go here, you can see the character quickly snaps instead of smoothly changing the legs and everything. The character snaps like that. See? So let's see how to resolve that problem. So yeah, for that let's here this angle, instead of directly setting it, maybe we could lerp it. So how? Let's try this. Oh. math.lab angle to the new value with time to delta time sorry, this float is defined right here, so therefore we can't use it like that. So I'm gonna have to move this outside this function. So let's define it here: private float angle. Right. And then yeah, that should be enough. Let's see. Oh, there is an error. Sorry. Let's see. Yeah, now you see that it doesn't change the value abruptly. It doesn't snap. It smoothly change the angle of the body, but the character is stuck there again. So we should be able to test it. If I add some location like that, see, it's not abrupt, it's smooth now, like that. Okay, so yeah, now the next problem we have is this. So let's say if the character is stopped in a position like this. So now no, let's go to a place like this. So yeah, if the character is stopped on this angled surface, across the angled surface, so you can see here the character legs, it doesn't take into account that this angle in the right direction of the body. So this hoof is under the ground and this hoof is above the ground. So in the next episode, let's see how to solve that problem. And also, maybe when we walk up in the hill, we would need some way to keep the head horizontal. Right, so for now I'll stop this episode here. Right, so if you would like to support my work, you can get the membership of the Patreon Club. Link would be in the description below, and the project files will be available for download through the Patreon page. And thanks for watching. See you in another episode. Goodbye.